Good morning and welcome to my Friday morning commute. It's very sunny outside, and today I want to share some thoughts on the plethora of hardware devices that are aimed at people with the intention of getting them into programming and making things. Things like the Arduino, the Raspberry Pi, the Mbed, the Beagle What's-It, and I'm unsure about them as a training tool for beginners. Let me make it very clear from the start, I'm not against the intentions of these devices. I think it's admirable that entities such as the Raspberry Pi Foundation are doing the great work that they're doing. They're producing fantastic pieces of hardware and a software ecosystem for a very, very competitive price and an attractive price. And it does make hardware accessible to all people. I mean, they're what, £30 for a Raspberry Pi device and you get a fully functioning computer. That's wonderful, brilliant. I wish those things did exist when I was growing up. And the same for the Arduino. I like the fact that it makes hardware programming available to all sorts, and you get the creative types making the art installations, and you get people putting it on drones and doing interesting things with sensors and IMUs, and that's wonderful. I love that creative exploration. It is educational. It is fantastic. But I take issue when these devices are used and are aimed at people who are looking for an entry point into the world of programming. And I think this for two reasons. I don't think that the blinking on and off of an LED, which is the typical embedded systems Hello World project, is suitably informative to get people who have never programmed before. I mean, I must stress this is for people who have never seen code before, to suddenly dump them to a C-like environment and have an int main function and get them to understand why an LED is blinking on and off. That's quite a tricky thing. I don't think embedded hardware systems are the correct platform for training people on how to program. And I mean real beginners here, people who have never coded before. The only exception would be electronics engineers who haven't coded, because they can then attach their circuits to a processor and they understand how their circuit behaves and they understand how their circuit interacts with the processor. So really all they're left with is a software option, and it may well be for a typical electronics engineer that a software ecosystem is more alien to them than the hardware one. So in that one situation, embedded systems as a training platform for programming is probably applicable and acceptable. So if we consider Raspberry Pi's approach, when the Raspberry Pi first came out, it was a small portable Linux computer where every program on the computer you could effectively press a button and have a look at the source code underneath. Now that is quite cool and probably useful for people with some programming experience who want to tweak, but I don't think that the best way to introduce somebody to programming is to look at the source code for existing applications straight away. Lesson 2 perhaps, but not lesson 1. But I also take issue with Raspberry Pi trying to become a platform to teach children how to program. I'm sorry about the camera glare at the moment. That was clearly a beautiful day. This is what it's like in the north of England. Anyway, the tools that the Raspberry Pi provided to introduce children to programming I find to be a little patronising, and I'm hoping that this year I might go some way to addressing by releasing some videos and some tools of my own. Anyway, we'll see what time permits. I don't want to knock the ambition of the developers of these applications, and they are quite polished applications. I just don't think children need to be taught how to code with cartoon characters and building blocks and drag and drop. Maybe that is a bit of an old fuddy-duddy inside me, but I just think it's too far removed from what's actually going on. And bear with me here, I wonder if the fundamentals such as sequence and decision making and looping and storage are really portrayed through the medium of cartoon characters and brightly coloured objects. I think that's patronising. I think young children are quite capable of understanding a list. a list of instructions on a screen, and they know to go from the top of the list to the bottom of the list, and that's a sequence, that's an order, and they can understand some fundamental conditions, that if some value is bigger than another, then to take a different list. The Raspberry Pi in embedded systems circles, I find to have a bit of an identity crisis. Is it an embedded systems device, or is it a full desktop PC aimed at being an educational device? The GPIO on the Raspberry Pi is poor. Blinking an LED on and off, fair enough. I know it does have accessories for cameras, but you really have to be sort of the advanced engineer in order to take advantage of these high-speed interconnects. You're quite likely designing your own PCB. So if you're already at that level, fine, fair enough. You're repurposing some of the more advanced functionality of the Pi. But let's take your beginner. They can blink an LED on and off, but then all they can do is clip other things to the GPIO, and even then it's not particularly exciting. And often you'll find with embedded systems that the debugging environments are either very complicated or very poor or non-existent. This could be very off-putting to a new programmer. The frustration of not being able to understand why your program is failing, not being able to step through your code line by line and do an analysis, which, by the way, I think is one of the most important debugging tools available. I also think that platforms like Arduino, in my experience, they don't seem to go far enough. They have a very C-like syntax, which I find strange, but they don't let me do C-like things. Making your embedded system do anything useful, other than perhaps blinking an LED or responding to a momentary button press, does require that you really understand the things that it's connected to. It has to be connected to additional peripherals, which means you have to understand power, you have to understand communication buses, you have to understand how to configure the device to operate in certain modes. Yes, all very well, you can drag and drop code from places, you can pull in abstraction layers which abstract all of the educational value away from doing the task. Which is not to say that an embedded system isn't a platform for people to use to learn things, but it's just as this, using it as an entry point to the whole world of programming, I think is a mistake. And what I don't want to see is the dumbing down of embedded systems tools to accommodate total beginners. And whilst we're on the subject of embedded systems programming environments, Microchip, what have you done to the PIC programming environment? Now, we've not had much traffic today, so this one's only going to be a short one. So I'm interested to know, if you care at all, what are your thoughts on using embedded systems as programming teaching tools? If you have any thoughts at all, please leave them below.